Viscosity is the internal friction that causes resistance to the flow of fluid, meaning the resistance that occurs between the layers of a fluid. Alright, let's say we have our grease or oil. You observe that there is this molecule that is causing the resistance of this grease or oil to move. That's it. The law governing viscosity, Newton's law of viscosity. What is Newton's law of viscosity? Newton's law of viscosity states that the shearing stress acting on the surface of a liquid is directly proportional to the velocity gradient. Mathematically, Newton's law of viscosity states that the shearing stress tau is directly proportional to the velocity gradient du over dy. From equation 1, I'm having a proportionality sign. Of course, constant will come in, right? The constant in this case, we have shear stress is equals to, this is the constant, this is du over dy. We call this equation 2. From equation 2, this is called the coefficient of friction. The coefficient of friction, or you say the dynamic viscosity, or you simply say viscosity. Anyhow you call it, you are correct. Alright, from here, from equation 2, you can make the dynamic viscosity the subject of the formula, meaning dynamic viscosity is equals to shear stress divided by du over dy. Call this equation 3. This is what Newton's law of viscosity is saying. By diagram, let's see what it means. Say this is your stationary plate, this is a fixed plate, right? Then you have this profile, and your fluid is going in this manner. This is the thickness dy. This is the thickness of the plate dy. Then from here, initially your fluid started with a velocity, that's u. Then at the final stage, this is u plus du, right? Then you have a force acting on it. Let's say you have this force. This is the force. Then of course this plate has its area, right? Now from here, what Newton's law of viscosity is saying is that the change in u, which is the final velocity minus the initial velocity, change in u is equals to u plus du minus u. Then from here, u cancel u. We have that change in u is equals to du. So this is the change in velocity. Shear stress, this is the shearing stress. The unit is Newton per meter square. dy is the thickness. This is the change in velocity. The ratio of du to dy will give us the velocity gradient. Then what else? Then dynamic viscosity, or you simply say viscosity, has its unit to be Newton seconds per meter square. This is how it works. From here, du over dy is equals to 1 over seconds. Come back here. Let's obtain the unit for dynamic viscosity. What's the unit for shear stress? You have it to be Newton per meter square, right? Newton per meter square divided by your velocity gradient, 1 over seconds. Of course, division will change to multiplication. Then you have Newton per meter square times this over 1. Multiply Newton seconds per meter square. So that's how you derive the formula for dynamic viscosity. Then you also need to know that your dynamic viscosity is measured in poise, meaning in questions when you see your units to be poise, then you are referring to dynamic viscosity. We have poise and we have Stokes. When you see your unit in poise, you are referring to dynamic viscosity. When you see your unit in Stokes, we are referring to kinematic viscosity. Alright, let's see what it means. We said for dynamic viscosity, which is Newton seconds per meter square, it is measured in poise. One poise is equals to, or you say it is equivalent to 10 to 1 divided by 10 Newton seconds per meter square. Then in centipoise, 1 centipoise is equals to 1 divided by 100 Newton seconds per meter square. Another way to express your dynamic viscosity is in Stokes. But before going into that, know this: your kinematic viscosity is equals to your dynamic viscosity divided by your density. And from here, symbolically, kinematic viscosity, this is the unit, this is the symbol, this is called nu, it is pronounced as nu, nu, equals to your dynamic viscosity. This is your dynamic viscosity. You have this, and what your density? Rho. So therefore, call this equation 4. From equation 4, your kinematic viscosity is equals to dynamic viscosity divided by density. Meaning, you can make dynamic viscosity the result of the formula by saying that dynamic viscosity is equals to kinematic viscosity times density. Call this equation 5. Then, 1 Stokes is equivalent to 10 raised to the power of 4 Newton seconds per meter square. Then 1 centi-Stokes is equivalent to 10 raised to the power of 6 Newton seconds per meter square. Then please change this. This is 1 divided by 1000, meaning 10 raised to the power of minus 3 Newton seconds per meter square. Why this is 10 raised to the power of minus 1 Newton seconds per meter square. Alright, this is all you need to know when it comes to viscosity. Example 1. A plate 0.05 mm distance from a fixed plate moves at 1.2 meter per second and require a force of 2.2 Newton per meter square to maintain this speed. Find the viscosity of the fluid between the plates. First thing first, list out the given parameter. Illustrate with diagram. Now, solution. A plate 0.05 meter distance from a fixed plate. Okay, let's say this is my fixed plate. This is the fixed plate. And there is this plate. This is the plate distance from a fixed plate, okay, moves, and this particular plate moves with a velocity of 1.2 meter per second and a force of 2.2 Newton per meter square to maintain the speed, meaning the shearing stress. Let's say we have this 2.2 Newton per meter square. The distance between the plate and this is the fixed boundary. This is the fixed plate. The distance between this plate and this fixed plate is dy, and the value is given to be 0.05 mm. We can simply convert to meter since other parameters are in meter as well. That's 0.05 times 10 raised to the power of minus 3 meter. Right? Now, from here, find the viscosity of the fluid between the plates. You are asked to find the viscosity. All you just need to do is to recall what the formula for Newton's law of viscosity. The formula says that shear stress is directly proportional to the velocity gradient, the u over dy, which implies that shear stress is equals to dynamic viscosity multiplied by du over dy. Then from here, make dynamic viscosity the subject of the formula. You then have that dynamic viscosity is equals to shear stress over du over dy, right? Now, from here, what's your shear stress? What's your du over dy? Your shear stress is given to be 2.2 Newton per meter square. Your du, okay, let's solve for du. Du simply means the final velocity minus the initial velocity, which means that du, the final velocity is 1.2 meter per second. The initial velocity, the place started with 0 meter per second, right? So minus 0, then you have 1.2 meter per second as well. This is my du, then my dy in meter, I have 0.05 times 10 raised to the power minus 3 meter. Substitute the respective value. So therefore, dynamic viscosity is equals to your shear stress, which is 2.2 divided by, what is du over dy? Your du is 1.2. What's your dy? 0.05 times 10 raised to the power minus 3. Take your calculator and input this. What do you have? I'm having 9.16 times 10 raised to the power of minus 5 Newton seconds per meter square. This is dynamic viscosity in Newton seconds per meter square. What about dynamic viscosity in poise? What you just need to do is to convert Newton seconds per meter square to poise, right? Because let's say you are solving OBJ question, right? Seeing this Newton second per meter, solving this rather, yeah, you solve for Newton second per meter square. What if your answers are in poise? How do you go about it? Just recall, we said earlier, one poise is equivalent to 10 raised to the power of minus 1 Newton seconds per meter square, right? Then from here, do your possible evaluation. If one poise is this, how many poise will be 9.16 times 10 raised to the power minus 5 Newton second per meter square? Okay, now put x here. This is the unknown. X poise, we don't know the value of x, so you are saying x poise is equals to 9.16 times 10 raised to the power minus 5 Newton seconds per meter square. Then from here, cross multiply. By the time you cross multiply, this value 9.16 times 10 raised to the power minus 5 times 1. What do you have? You still have that same value, 9.16 times 10 raised to the power minus 5 equals to x times 10 raised to the power minus 1. What do you have? X 10 raised to the power minus 1, right? X poise, x is unknown. Divide both sides by 10 raised to the power minus 1. Meaning x is equals to 9.16 times 10 raised to the power minus 5 divided by 10 raised to the power minus 1. From indices, by the time we do your indices, you can write this as 9.16 times 10 raised to the power minus 5 minus 1, right? The minus will go up, then this division is minus. Or better still, you can input it in your calculator. Then, moving on, we have 9.16 times 10 raised to the power of minus 4. So therefore, your dynamic viscosity is equals to 9.16 16 times 10 raised to the power of minus 4 poise. So this is the answer of dynamic. This is the answer for dynamic viscosity in poise, whereas this is the answer for dynamic viscosity in Newton seconds per meter squared. So this comes to the end of this video. Stay tuned for more examples on Newton's law of viscosity. Do well to like, subscribe, comment, and share. And share this video to your friend to watch as well. See you in the next video.